So I just really quickly want to do a shout out and acknowledgement of all of the other co-authors who are on this. I don't necessarily have attribution for all the slides, and so I have borrowed a lot of material from other folks who have either created whole new ways to use these products or just really expanded out on some of our original ideas. So what I'm going to be talking about today is this PODS process. PODS is something that hopefully people are starting to become familiar with, and I'll get into the details of what that really means. But what this, if we kind of think of an overall framework, we are talking about strategic wildfire risk planning. So we're in this planning phase, and then we're trying to figure out how to move that planning into more informed decision support, so that when we actually have an ignition on the ground, we're integrating that fire into the management plan for that piece of ground. And so we're trying to stop separating fire response from land management planning. So I'm going to talk about some of the applications, some of the lessons we've learned, and then ideally some of the future directions if I have some time to go that way. So real quickly, what's the framing for all this? Why are we doing all this type of work? First of all, we are tearing directly into those national priorities for wildfire response. We're trying to understand where are the safest and most effective locations where we could respond to a fire when we need to. We're really trying to facilitate how the risk of that fire is going to be managed both at the federal level and within federal agencies, but then with all of the landscape stakeholders, all of the partners in this landscape. And I really appreciated seeing that poll early on to see some of those, that kind of cross-cutting of partnerships. As you stated earlier, Xander, that fire knows no boundaries, right? And so fire control opportunities also don't really know any of those boundaries. We're trying to expand decision space by having a lot of these conversations in the preseason. So if we can plan our response, we can change that default response, then we start to open up a whole series of possibilities for how we could handle a fire under the right conditions, getting the right fire in the right place at the right time, but then also recognizing when that's not the right fire, that's not the right place, and we should have an appropriate response for that. We're really trying to figure out how to facilitate this preseason engagement and coordinate across boundaries, understanding again that fire knows none of these administrative boundaries. And then ideally, we're taking the risk profile that's out there and the fire modeling that's out there and moving it into that operational realm. And so handing this off to an incident commander, handing this off to fire managers so that they actually have tools in their back pockets that they can make it actionable. So the way that maps out is we have this planning phase. We have an execution phase that tears directly off of that, and oftentimes needs to be much more flexible than what we come up with in planning. And then we monitor those outcomes. We look at, were we successful? Did we reach those objectives that we planned for while we were planning? And then we take that feedback, ideally that's external feedback or feedback directly from the stakeholders who are managing that fire, and we improve our products. That's what we've been trying to do for the last 3 years anyway. So just a little bit more framing, what are PODS? Over on the right here, you see an example picture of what a PODS map can look like. So what we start off is we look at a fire-prone landscape, a place where we're concerned about fire or interested in how fire behaves on this landscape. And we work directly with fire managers on that landscape to identify what we're calling these potential control locations. Now, we can get there a number of different ways. We can use some analytics to help us kind of hone down all the different opportunities. We can rely directly on long-time experience on this landscape. But one of the things that we've learned, and going back into kind of fire ecology studies, is that fire tends to behave the same way in the same locations year after year after year. At least under a certain range of conditions, right? When we're not functioning at extremes, fire becomes pretty predictable. And so we can work with the fire managers themselves and some of these analytics to get at those patterns that we can work with. Once we have those patterns identified, we can link these control opportunities into these polygons that we call PODS. So PODS are these potential wildfire operational delineations. It's this polygon where we think that the edges of this polygon are relatively good fire containers. That's a place where we think we could hold a fire either with suppression resources, or maybe we're just leveraging some natural component of that landscape that slows down the fire, or that allows us to just keep it contained there. Once we have this network of polygons, now we want some information that we can fill in inside those polygons. So that's where the quantitative wildfire risk assessment comes in. That's basically this taking stock of all of the things that we care about on the landscape. Those could be the built assets that are out there. Those could be the national functioning system. There could be the wildlife, a lot of different things. And then we try to understand how the most likely type of fire that's going to happen on this landscape is likely to affect those things that we're managing for. So when we overlay our suppression opportunities or our opportunities for fire engagement onto that map of wildfire risk, now we can start to summarize that risk in a way that makes sense operationally. So we move into these strategic wildfire response zones. And if we can do that, then we can start to change the default response of fire from something like, say, a full suppression area to, yes, full suppression where it's necessary, but it's not always, doesn't always have to be necessary. Oh, I'm seeing a bunch of chat stuff going on here. Let's see here.
No, don't worry about that. I'll keep an eye on the chat, and if something comes up where we got to interrupt you, we will, but we'll hold most of the questions to the end.
Okay, that sounds good. So real quickly, I just want to kind of see how this all tears off down to the lower right here. What we're doing is we're working directly with the existing fire management system nationally and at state levels, where we're looking at things like, what are the management action points that are out there? How does that tier into pods? What are the fire response zones that a lot of forests or other land managers have already identified? How does that tier into pods? We look at management requirements in something like WFDS or in our land and resource management plans. Those can all tie directly into these pods. So we can start to look at these dispatch zone boundaries. We can start to pre-plan our responses given a range of different possible conditions. And then ideally, if we have time and we have the engagement of our stakeholders, we can start to move into the simulation realm. In that simulation realm, we can say, okay, given this pod under these conditions, this is what you can expect from us. We start to build transparency into that process. And so we start to have this shared understanding of how fire behaves. Oh, and there we go. So a big part of this process too, and what we kind of bring to the table as kind of these new next steps, is this idea of analytics. And one of the ways this has actually been characterized is Moneyball for wildfires. So can Moneyball for wildfires fix how we manage these fires, right? Now that we have all this information, we now have supercomputers that can harvest this information and help us learn from the patterns that we're seeing. How can we leverage that to help us get to a more informed incident response? We're not trying to take over that incident response, but we're trying to give the best possible information to the right people so it's at their fingertips. When they make those tough decisions, they got everything they need in front of them. So some of the analytical tools that we talk about, these are kind of the three primaries at this phase right now. We have something called the Potential Control Locations Atlas. That's using that fire history. How is fire likely to behave on the landscape? We have quantitative wildfire risk, all the things we care about and how they're likely to respond to fire. And then we bring in that operational side. So here we're looking at Suppression Difficulty Index. That's basically how a fire responder themselves sees that landscape. Where are the suppression opportunities that ideally would be the safest and most effective? And I'll get into some of the strengths and weaknesses of these products. But first, Xander, if you can take over control, and we'll do just a really quick video that shows how all these products fit together.
Welcome back to the Ponderosa Pine National Forest, where staff are working together with the Wildfire Risk Management Science Team to create more proactive wildfire risk management plans. One of the challenges of spatial fire planning is identifying control locations where operations can be safer and have a higher likelihood of success. This is especially important because control opportunities often don't align with ownership boundaries. With a plan in mind ahead of time, everyone involved can be clear on the best actions to take, even in a cross-boundary fire. The science team brings several tools to the table for this effort. The basic ingredients of these tools are intuitive and designed to complement local expertise and judgment. Quantitative wildfire risk assessments, Suppression Difficulty Index, and potential control locations that help form potential wildfire operational delineations, also known as PODs. The quantitative risk assessment uses fire modeling and expert analysis to estimate benefits and losses from fire. Suppression Difficulty Index provides an assessment of the potential hazards and opportunities for fire responders by balancing expected fire behavior with access and mobility. The Atlas of Potential Control Locations maps local conditions where fire lines have and have not been effective in the past, and provides a measure of operational opportunities and challenges for suppression. By overlaying suppression difficulty and potential control locations on a map of quantitative wildfire risk, we develop pods that summarize risks to important values while highlighting opportunities to effectively engage fire. The science team is already deploying these tools in planning applications on National Forest System lands across the western United States, including for real-time decision support on dozens of large fires. Incident management teams use these tools to prioritize responder safety and assess suppression opportunities on fire operations. And forest managers and their neighbors, like here on the Ponderosa, use these tools to integrate fire into landscape planning, prioritize fuel treatments, and create or improve control opportunities to reduce risk to things they value. Can the Wildfire Risk Management Science Team help with assessment and response planning in your area? Contact us to find out how we can help your forest and neighbors plan for the next fire.
At a very basic level.
Whoops. Okay, Kit, you should be able to take the share back.
All right, I'm working on it right now. There we go. And we're back. All right, are you seeing my atlas of potential control locations?
Yep.
Okay, so that gives kind of the 2.5-minute summary of what strategic wildfire risk planning is. And now I'm going to go in a little bit more of the details of these analytics, but I don't want to get into the weeds. We're really going to focus much more on applications and then these next steps. So the first question we asked was, where on the landscape are fires most and least likely to be successfully contained? We can get at that by looking at the history of fire on a landscape. So we look at this spatial representation of suitability for fire containment. We look at these landscape features where fire either continues spreading, oftentimes that'll be like a mid-slope situation or continuous fuels, or where fires tend to get hung up. So where's that perimeter form, and what are the conditions of where that perimeter formed and why? So what that looks like when you have a really mountainous terrain like this is we can start to break up this landscape into opportunities and challenges. So here we assume that typical fire season weather and conditions from that fire history. And that is one of the weaknesses potentially of this model, is that it only has enough information in it from the history of fire that you include. And so we're looking at historical suppression effectiveness. We don't know exactly how today's fire, tomorrow's fire is going to behave, but if we assume that this fire is like what we've seen in the past, these are the types of opportunities and challenges we'd see out there. That the number scheme that you see up here is in red, we have less than 10% chance of containing a fire in those red zones. These blue zones are showing a better than 75% chance of fire either at least getting hung up, if not stop entirely, when it encounters those types of conditions. So one of the ways we use this analytics tool is if we can link together as many of those blue zones as we can actually start to develop those pod boundaries pretty effectively. Moving on to the next step, looking at quantitative wildfire risk assessment. The first thing we can do is just run a bunch of fire modeling. We can look at what's the burn probability for anywhere that we're interested in looking, and then what are the intensities we can expect. So what types of flame lengths can we expect when an area does burn? We can also just filter that down to the areas that we're really concerned about. So what are the areas we're concerned about burning under extreme flame lengths? And here for an example is just like the entire state of Montana. Where would we expect those extreme flame lengths? Now what's interesting is when you have this fire modeled information along with the things that you care about. So if we're actually looking at the values that are out there on the landscape, we can start to get to this exposure side of the equation. So we're looking at extreme fire behavior and a map of those values that we care about, but we can go deeper than that. So once we're understanding where those values are, let's talk about what those values are. And so some of the language we use is these highly valued resources and assets. And we break that down to understand how each of these actually maps out across the landscape. Oftentimes, we'll have 30 or 40 or 50 different values that we're independently looking at. And then what we want to understand is that how each of these values responds to a certain type of exposure, so a certain type of flame length we could expect. And with that, we can develop basically a response function. So if this value is likely to experience this flame length, this would be the result. Would it be a net increase in the value or a net increase in the usefulness of that product, or would it be a net damaging effect? So one way to think about that is things like human habitation, they pretty much never benefit from fire, right? So we're gonna have a negative response function under all flame length conditions, but there's gonna be more negative response as our flame lengths get longer. One way to think about that with a fire adapted system would be a system that surface fire maybe could be improving that landscape. We could be improving something like a ponderosa pine system, but at a certain threshold, we are going to cause damage. So we basically come up with this response function for each of these values we care about. Once we summarize all that information and we rank those things against each other, we can get basically a wall-to-wall map that looks at that risk. Here we're looking at net value change for all of the values that we care about. This is from Region 6, an assessment that was done by Pyrologics and strongly informed also by a lot of work from Rick Stratton. And in this particular example, we're looking at how fire intensity and effects interact with one another. So if we can assume a certain fire intensity and where those things actually are out there on the landscape, we can get a sense of what that conditional net value change is. So is it going to be a net increase in the value, a net positive benefit from fire, or a net negative outcome from fire? The hot colors you see on here are areas that have that negative outcome from fire. The cooler colors are areas that could actually benefit from the right kind of fire and the most likely type of fire. Now, the one thing that's missing from this is the probability that fire is actually going to happen. So when we bring in fire probability, now we're in the expected realm. We're actually bringing in more information. This is probably actually a better tool for prioritizing where we want to get our fuel treatments out there, because we now understand, well, what's the chances of that thing even getting exposed to fire? So that's one of those other tools that we can bring in. And then lastly, we get into that operational side. So we're looking at Suppression Difficulty Index is basically how a firefighter sizes up the landscape. What that looks like is, what's the potential for extreme fire behavior? What are the flame lengths and the heat intensities we can expect? Kind of a hauling chart if you think of it that way. And then you can actually temper that by the mitigating factors you can have. So how quickly could you cut line using either a bulldozer or with a hand line? With a 20-person crew. What kind of road access is out there? What kind of trail networks are out there? So kind of what are all of the ways that you could potentially counteract that fire hazard on the landscape? Once you have that, you can map it out. And here you can see these red colors are these areas that are considered very high suppression difficulty. The blues out there have the lowest suppression difficulty, so the easiest places to engage a fire if you had to. You can put these things together, and that's how we get that strategic response. So at the top here in A, this is that atlas of potential control locations. Again, those cool colors are areas where a fire is likely to hang up anyway. So let's leverage those. Let's try and figure out if we can use those to develop our pod boundaries under the right conditions. Again, this is just information, so this has to be interpreted by the fire professionals. We're not trying to automate this process, but we do want to get those fire professionals comfortable with reading some of these analytics and then deciding if they're useful or not. The next slide over here in B, that is just pulling out the best available opportunities. And then we take those opportunities, we map them onto the risk. That's what you see C. C is the blue zones are likely to be benefited from fire, red zones going to be harmed by fire. And then we can start to summarize that risk along these gradients. So again, on D here, these green zones are areas where we'd be relatively comfortable with fire. Red zones are areas where we're likely to have a lot of damage from fire. So we can start to break out that risk in a way that's operationally relevant. So now we move into the planning phase. Once we have this framework that we can work with, we take it out to the stakeholders and try and figure out how this is actually going to work on the ground. This is an example from the Coronado National Forest from just 2 weeks ago. And you can see we've got the analytics maps out there. We have all the resource specialists in the room to talk about the values. And we run these 2-day and 3-day long workshops to develop a lot of these tools and work directly with the stakeholders for decision making. One of the big advantages of this framework is spanning social boundaries. So what we're looking at here is oftentimes within organizations, you have resource specialists and then you have fire folks. And oftentimes they don't talk to each other unless smoke is in the air and you need a resource specialist out there telling the fire person where not to go. But when we're in the off season, we can have a lot more constructive conversations. And so we can talk about, well, if you're going to get a fire in this area, what's the right kind of fire? What does that look like for that resource you're trying to manage for? In the bottom picture here, you can also look at when you're starting to draw these pods, these operational opportunities for fire suppression. We can break out of working just within, say, a federal ownership, where we can start to bring in municipal fire responders. We can look at other federal partners, for example, BIA or BLM, or we can look at our state lands and bring those fire folks together to start looking at these analytics and saying, okay, this is a relatively objective view of how fire behaves here. How are we going to draw our boundaries to try and contain these fires where it's going to be a relevant thing to do? So one of the really nice things about this system is it starts to acknowledge this fire knows no boundaries, right? And so here's an example from the Santa Fe and Carson National Forest, actually right where Xander is, right there's Santa Fe right in the middle there. And here you'll notice these big green zones are the national forest land, but there's a lot of other partners at the table when we were developing these pod workshops. And so we had BIA, we had National Park Service there. We are working directly with other stakeholders and city stakeholders, and we're not doing this alone. So the Nature Conservancy was part of this. At Colorado State University, CFRI had a big hand in this as well. So we're really expanding out and not just working on federal lands, but starting to bring in all those partnerships. The other thing that we've been able to do is once we have these kind of initial underpinnings developed, now we're starting to tier directly into, say, BLM has seen this map. They said, okay, we'd like to see that now on our lands. So that moves into the phase 2 and the phase 3 workshops. We start to bring in more and more partners, tier off of that original work, and then ideally over time, we also refine these pods and make them better. They become this kind of self-sustaining system. So what does it look like when we're actually working this plan? Here's just one example I'm going to talk about from the Tonto National Forest, but we've got a lot of examples out there. This is an article that we wrote in 2019 detailing some of the outcomes from the Pinal Fire. So the first thing that I wanted to draw your attention to is developing these strategic response zone maps. So for the Tonto National Forest, this is something I touched on in the last talk too, but this is now something we're doing nationally. Where we have landscapes involved with this. And that is classifying our landscapes by risk, bringing those opportunities to the risk profile that's out there, and classifying, basically changing how that initial response happens. So in these red zones you see up here, these are our protect zones. These are areas where for the most part we're not comfortable with fire. Fire is likely to do a lot of damage. We have a lot of very fire sensitive resources and assets. And so those are areas where under most conditions throughout the year, we're unlikely to see fire being a beneficial thing to do. So we're going to be in kind of that protection mode. Restore zones have a lot more flexibility. These yellow zones that are out there across the landscape are showing us that the right fire under the right conditions could do a lot of good. The wrong fire under the wrong conditions could be very harmful. And so it really comes down to that assessment of, okay, we have an ignition. Where are we in the fire season? What resources are available? What are the expected conditions over the next couple of weeks if we were going to take a response to potentially manage this fire for resource benefit or for risk reduction and not go and do incident or an immediate attack on this thing? What are our options that are out there on the table for getting a real benefit out of this fire? Green zones are areas that we've identified as most fires actually are beneficial. So these are areas where your typical ignition under normal conditions is likely to be a lot of benefit for that system. And so the default oftentimes in these green zones is to manage that wildfire for resource benefit or just to monitor it and let it just do good. On the Tonto specifically, they had two other classifications. They had this exclusion zone, which is Sonoran Desert that's been invaded by African savanna grasses. That's a desert system that now does burn, but is not benefited by fire. The reason they call it exclude and not protect is there's not human life at risk there. And so they don't want to risk firefighter lives trying to save the Sonoran Desert. But at the same time, they do want to keep as much fire out of that system as they possibly can. And then lastly, this is a classification that we see in a lot of places, is this high complexity zone. High complexity is an area where you cannot separate the values likely to be benefited from fire from the values likely to be harmed by fire. And so ideally, this is a transitional classification. These are the pods that need the fuel treatment dollars to create those suppression opportunities where necessary, so that you actually can have a protect zone where you have areas you're trying to keep fire out of, but then you also have potentially a restore zone or even a fire maintenance zone once you're able to develop those other opportunities. So you're basically trying to slice these orange pods smaller and smaller, and so you can really characterize that risk as best you can. So moving into just a couple of actual fire examples, I'm going to start actually at the end of the fire season of 2017 up here in A. That's the Brooklyn fire. That was an over 30,000 acre fire that happened during the monsoons. Because of that, it was ignited in a green zone. There was very low risk to the things that they were managing for out there, and they just monitored that fire. That fire cost a total of $250,000 to the forest. Very low cost and very large benefit for that fire burning in that location under those conditions. B, the Highland fire actually occurred under peak fire conditions. That was the end of June. Temperature spiked over 110 degrees. It was in one of these red zones. They already knew they wanted to protect from fire. There was a lot of potential hazard of fire in that system. And so they immediately went to a type 1 team. They did keep that fire as small as they possibly could, but it was expensive. They had a lot of heat stroke and other exhaustion issues with that fire. At the end, they were able to keep that fire as small as they possibly could, but it was not a fire that they wanted to have in that area. And then the last fire down here in the corner C is the one I'm going to talk about a little bit more. So the Pinal fire was the first fire of the season on the Tonto. Happened on May 8th, and it was under much more mild conditions. They had access to a lot of resources, and they had done a ton of homework, basically greasing the skids with the surrounding community of Globe, with the county commissioners and other folks to say, if we can get this type of fire in this location under these conditions, we'd like to have the opportunity to do a risk reduction treatment for you. We'd like to manage this fire to get rid of the heavy down fuels. This was a ponderosa pine system at the top of the Pinal Mountains that hadn't burned in over 40 years, had a lot of fuel buildup, and the idea being that this system does burn under extreme conditions, but wouldn't it be nice if we had an ignition under mild conditions to remove a lot of that risk into the future? So what does that look like? Here's an example of that mountain range. These are the Pinal Mountains. And you can see this is the actual ignition location for where that happened. It was up near the top of the range. That gave them an opportunity to back this fire off the mountain range and moderate that fire behavior and get a lot of benefit from it. But the other thing to draw your attention to is at the very bottom of this map, you can see that there is wildland urban interface. There are homes they're concerned about. And so they want to keep all of these things in mind. Also at the very top of the mountain, they did have communication structures. They had cabins and other things. And so given the time, under mild conditions, they were able to account for all of these potential risks that were out there and tactically get exactly the fire that they wanted. So if we look at something like the Potential Control Locations Atlas, this is how it mapped out. They had developed a pod boundary that used these green zones on here, and so they actively managed to those. And so as this fire progressed along the landscape, you can see the fire starting, and then as they actively used aerial ignitions, they used drip torches and other things, their intention was to burn as much of the inside of this pod as they could under the right conditions to get that fuel treatment that they wanted. You can see that the control probability was very low in those red zones anyway, and so there wasn't really a need to try and keep the fire out of those areas. They minimized their exposure of the fire responders, and they got a really nice treatment out of it. As fuel types transitioned coming down that mountain, they moved from a forested type into a shrub system. The fire behavior also changed. And so they did do a back burn on May 29th, I believe. And that back burn created this backstop so there wasn't any way that fire could continue to come down and threaten any of that wildland urban interface. So in the end, they actually ended up treating pretty much an entire pod with a natural ignition. And that was basically a 7,000 acre fuel treatment that would have been very difficult to pull off outside of fire season. And it was a huge benefit to the city of Globe at the end. So a big part of this is once we have these tools in place, we can move into the decision support realm. We can look at how this tiers directly into things like WFDS. We already have pods loaded up, and now we can start to think about how we could leverage these pods when appropriate so that we have nice anchor and flank locations. And we also have these strategic response zones already defined in something like WFDS. So here's the pod network from 2019 from the Santa Fe and Carson landscape and how they managed the Francisquito fire to leverage that pod network. Another really nice thing is once we have the strategic response zones out there in the pods, drawn, we can start to track the use of these and understand how are these being used by the fire professionals, and how is this tying directly into land resource management planning, and how's the communication going with that. Here you'll see that 6 of the 7 fires that burned in 2019 on the Santa Fe and Carson landscape directly used these pod boundaries. The Naranjo fire that you see here is in one of these protect zones. That was not a place they could easily leverage a pod boundary, so they went direct. They kept it much smaller. The complexity was not something they wanted to expand out further into the fire season. But you can see that a lot of these fires still average anywhere from 700 to over 3,000 acres, but leveraging this pod network as they went along. So not everything has been all roses and sunshine for the rollout of these things. We've learned a lot of lessons along the way too. So for example, in 2018, the Pole Creek fire was a fire that was supported by RMAT. They didn't have pods on the ground, but they did have these analytics. They asked for the analytics from risk management assistance teams, and they were able to get the potential control locations atlas and suppression difficulty index. But what they didn't expect was that this was not a typical fire year for them, and they didn't have conditions that they'd ever seen before. You can see that directing this quote from the forest supervisor. And just a real quick synopsis from the report here, the PCL predicted there was a good chance of this fire would form an edge to the north and east of where the fire perimeter was on September 10th. This is consistent with what local managers and the IMT expected. But the weather and fuel conditions that were actually experienced pushed the fire through a potential control feature that both the PCL indicated and some firefighters believed would hold. So the PCL and firefighter alignment was there, but conditions changed. The PCL, which is based on this machine learning algorithm, was equally surprised that this fire did not form an edge after reaching Highway 89. This speaks to the uniqueness of the weather and fuel scenario that resulted in fire behavior unlike that experienced by either firefighters or historical data used to train the PCL model. So again, because we're working within this extrapolation idea, we have to have all of the right information going into the model, or we won't be able to account for conditions moving forward. We've also seen some mixed results. A big learning opportunity was the 2019 Woodbury fire over in the Tonto National Forest. They'd had a strategic response plan in mind for, this is gonna be the 3rd year of using it. But 2019 wasn't a typical rainy season for the Tonto. They actually had much higher winter precip. And as you can see over here in the upper left, huge fine surface fuel loadings inside the Sonoran Desert. So they had fuel connectivity that was not typical. They hadn't seen anything like this in more than 15 years. So this was not a typical fire season for them either. So they immediately called me and said, you know what, I don't think our pods network is gonna work the way we want it to this year. So can you rerun a model for us that accounts for some of these fuel changes? We did that. And one of the things that we found was to the northwest and southeast, they did hold this fire along predefined pod boundaries. To the south, as you can see in the image here, the fire actually just got hung up in those low probability of spreading areas. But to the north, this fire blew right through the initial pod boundary. And the reason for that was that the pod boundary they had drawn was a trail system that in the Sonoran Desert under typical conditions was completely defensible. But with a carpet of connected fuels, that trail system was no longer a holding feature. And so they did have to fall all the way back to a major interstate to actually stop this fire. So what this brings into to mind is that while this general area is in one of those restore zones, it's an area that could benefit from the right kind of fire under the right conditions. This is Superstition Mountains. Where this happened during 2019, this probably would move into that red zone. This is an area where conditions weren't right for a fire for resource benefit. This is an area where fire was going to do what it needed to do or do what it wanted to do, regardless of what the suppression actions were that were taken. So there's also a lot of challenges to implementation. Here's an example from the Bitterroot front just south of where I live in Missoula. And here you can see in the lower valley area, you have a lot of control opportunities. Problem is that ownership in there is all private land. Where you start to see the forest boundary come in, that's the yellow lines that you see on the far left and far right of the picture. Those all align with very low probability of successfully containing a fire. So that's the challenge that forest managers see, is their administrative boundaries are not control locations on the Bitterroot National Forest. And this is actually very common across the entire West. Admin boundaries weren't drawn with fire containment in mind. It was basically, where's the merchantable timber that's out there and how do you want to transition into other fuel types? And so this is one of the big challenges. It's useful for communicating with the public about what are the realities of fire on some of these landscapes, but it's also very difficult to draw a pod, for example, in some of these areas. Another thing to think about is landscapes that are driven very much by initial attack strategies are also somewhat difficult to put pods onto. When we look at things like the national grasslands out in Oklahoma or in Texas, those are areas where they pretty much always try to stop fires as small as possible because 7 to 10 days of the year, they get these sustained winds of 40 or 50 miles an hour where nothing works. And so as long as the fire's out before those winds hit, everything's okay. And so these are some of the challenges that we've started to run into at these workshops. And so it's important to work with the land managers and basically come up with a solution that makes the most sense to them. The key is if you draw these pod boundaries and you have the conversations in the preseason, you can communicate those limits of fire suppression. You can bring transparency to the decision making so people have realistic expectations of fire. Another thing that we really try to do is target these mitigation opportunities. So communities especially, a lot of values at risk. If we look at potential control locations around Ashland, Oregon, there's basically nothing until you hit homes, unfortunately. And a lot of that interface is very non-defensible. It's an area where fire is very likely to spread. That dotted line you see on there is the forest boundary. We look at suppression difficulty index, and again, what we see is that those red zones, those areas near the forest boundary, are also the least safe zones to operate. Those are areas where you're most likely to have extreme fire behavior. And then lastly, if you look at the concentrated risk on the landscape, the areas where you could stop a fire are the areas that are most likely to be harmed by fire. So these are some of the challenges as we roll this out to figure out how do we have these conversations in the preseason so that we can start to separate these sensitive values at risk from the control opportunities. So how do we concentrate our field treatment dollars to create opportunities, and how do we work with these communities to make them fire-wise? How do we make it so that these aren't bright red communities, but maybe these are fire-tolerant communities because the buildings there aren't going to burn to the ground when they have a very low flame-like fire coming through them. So we have a lot of expanding applications for this work right now. A big part of it is, first of all, planning for beyond federal lands, and especially expanding out of the Forest Service into Park Service lands and BLM and other things. But now we're working directly with municipalities. We're working with state partners a lot with some of this. The state of Oregon now is interested in trying to understand how they can scale this pod concept up to the entire state level. And we're starting to engage with the state of Montana up here in Region 1 on some similar conversations. A lot of this has gained traction through the use of these National Remote Incident Support Teams. That's the risk management assistant teams that also kicked off in 2017. We're looking for some good analytics to help with decision support, and these just fit that bill really nicely. Another thing that we're moving into now is kind of this training and integration curriculum. So M580 down at NAFRE this year used a lot of this information for introducing it to fire managers on the ground, but also the NAFRE staff have seen some of these presentations and want to work with us on developing new curriculum. There's also potential for integration directly into the National Fire Danger Rating System. What that could look like is kind of this top-down approach where NFDRS gives the fire danger and weather, and we have this idea of where the fire danger rating area is. So coming from the top down, much coarser scale, we can start to get into these response zones. And then taking these tools that we've been developing, how do we move that up from the bottom so we can look at what are the values that are out there, what are our suppression opportunities, and what's the safety profile if we wanted to take action. So bringing those two things together, you get an action point where we have ground up information, top down information, and then we have a decision space we can work with. As we move into tracking progress towards integrated landscape and fire management, one thing that we've seen is, for example, in our longest term applications on the Tonto National Forest, where they're leveraging these pods, getting the right fire into the right place, they're actually changing their risk profile. They're actually reducing risk for that area around the Pinal fire, for example. And as they start to tear off of these pod boundaries, they're actually hardening them. And so that potential for fire spread across these pod boundaries actually goes down the more they reuse those pod boundaries. Another thing that's really important to talk about, especially in the kind of the preseason, is this idea of a seasonal risk adjustment. So we develop these tools looking at the most likely conditions, but understanding that those conditions change throughout the year. And so while we develop something with like the most likely flame length we would expect to see, we understand that under extreme conditions, those flame lengths get a lot bigger. And under shoulder season conditions or under prescribed fire conditions, those can actually get a lot shorter. And so the thought being that that strategic response zone map actually should be changing colors throughout the season. And that's something that we have been looking at. We could either automate that or just work directly with the land managers, decision makers on the ground to kind of let them track that in their own minds in terms of how that risk profile changes through time. So real quickly, touching on some of the lessons learned, the Pole Creek fire, we were in no analog conditions. And so when we're training a model off of a history of conditions, and then we're moving into a no analog condition, that model doesn't work very well. And that's one of the things that we are actually quite concerned about with climate change. If we want to try to account for some of that, maybe we should just start training our models on more extreme conditions, on those few conditions that are out there, and so we can start to capture some of those tails of the distribution. Woodbury fire, also rare conditions. This would be a change in fuel loadings, something that does happen cyclically. It's part of the El Nino, La Nina system, and so maybe we have pods during a normal year and we have pods during an El Nino year. So we can actually start to account for some of that. Two fires from 2017 that also didn't behave well, according to the models, were things like the Lilo Peak fire and the Rice Ridge fire, where we had an overnight 40 to 50 mile an hour wind event where we already had a large fire, and then it just threw firebrands 5 to 10 miles in some cases, and just ended up doubling the size of these fires overnight. So we went from maybe a 40 or 50,000 acre fire to a 100,000 acre fire overnight. At the moment, we don't have ways to account for that. If we start to integrate things like fire weather, we can say pull back, but we can't say is what's actually going to work. And what we are learning more and more is that the typical conditions, the conditions that happen 95% of the time, are the ones that give us our success stories. And a huge part of this is the strength of the structured process. So we have structured decision making so that we can justify what we did. It's not even so much about what are the analytics or what's necessarily even the fire outcome, but how do we get there? And if we can track that over the entire decision making, we can build trust. We can start to explain why it is how we do what we do. And the last thing too is the nice thing about these analytics is they build transparency. They help to bridge these divides between stakeholders because they're objective. You can look at this and say, oh, that's the risk that's out there on the landscape. Oh, that's how fire behaves on the landscape. And oh man, we're not gonna be able to stop that fire before it hits these things we care about. And so by building in that transparency, you can start to bridge gaps between organizations. Oftentimes there's federal objectives for what to do with fire, there's state objectives to do with fire, and they oftentimes don't mesh very well. But if you can have these conversations in the preseason, you can get around some of that, or at least you can meet in the middle somewhere. Real quickly, in terms of how we've been doing so far with this, we are up over 40 national forests now engaged, which is pretty cool because back in 2017, we had one forest we were working with directly on this process. This is largely in part to all of the co-authors on this paper or on this presentation who have taken the initiative to really move this out into wherever they're from and working with those stakeholders. And so we took these ideas and now we're expanding them out, and we have a pretty long list of folks that we're still trying to engage with. Incident support applications here have also been kind of the spearhead of demonstrating these products. Real quickly, if I have a couple minutes to go through it, I want to talk about some of our next steps. So we have continued development of support applications. Once we have this pod identified and a strategic response zone for it, now we can put information back inside there to help the incident commander make decisions or help the fire manager make those decisions. So we can map in things like the wild and urban interface. Where's the water that's out there in the landscape? What are the infrastructure that they're going to want to keep in mind? And what are the timber resources? So we could kind of look at a whole series of different values and how they map back out onto the pod so that you have a tactical approach to deal with that risk. We can also start to rank our pods against each other. We can look at things like burn probabilities. We can look at wildland urban interface density, road density. Where are opportunities that are out there? What population are we going to be dealing with inside these pods? We can look at the history of how these pods have behaved in the past. So we look at past fire behavior. We can look at fuel treatments. And then say we don't want to have a large fire inside this pod, well, then we just pull up the analytics. We pull up the potential control locations atlas and say, okay, inside this pod, where's the second best? Where's the third best opportunity to stop a fire if we need to keep this thing small? So we can bring in a lot of that information, and ideally we can tier this off of decision support systems like WFDS. So future directions, we're also looking at doing things like looking at daily growth of fires and taking all that into account, overlaying that with fire weather and doing a much better job of trying to account for how fire weather affects those potential control locations and how likely they're likely to hold under certain conditions. But then also, what were the conditions for resource use? Were there suppression resources there? Were there aviation resources there? Why did that feature hold or fail? And what was associated with that? And we can start to hopefully develop some of these holding thresholds. So we know that we can hold something up to a certain point, but when conditions get too extreme, it is time to fall back and try and make sure we can protect ourselves. Another big gap in this understanding is snag hazard. It's another one of the huge hazards that's out there for any fire responder, and we're looking at a number of different ways. Chris Dunn, one of our collaborators, has developed a snag model. He has a paper out on that looks at how you can actually model snag hazard through time. So if you understand the current condition, you can forecast it moving ahead 5, 10, 15 years and understand how that snag hazard changes. But we can also look at things like satellite mapping. So with satellite mapping, we can look at what's our current condition, what's the time since disturbance, what's the density of snags we need to be concerned about, and what's the right conditions for entering that stand or not, where are the areas we'd really need to avoid. And then lastly, the big thing is tying all of this into our national fire priorities. So our national fire priorities drive the funding for this work, but also tier directly into each of these things. And so we're able to check a lot of boxes with this work, moving into things like the Dingle Act and basically being able to account for dollars spent and what we got for it and tracking those changes through time. So there's a lot of potential to tier this work directly into the federal funding and the federal priorities for where this goes from. So I'm going to stop right there. I know I don't have a ton of time for questions, but I'm available to stick around for 10, 15 minutes if people have questions, and I'd be happy to entertain them.
Great. Well, thank you so much, Kit. That's really interesting, and it is fun to see how much progress you guys have made since last time you presented. So hopefully we'll have a couple of questions come into the chat box. I will note that Will Harling emphasized the importance of seasonal risk adjustments to ensure success. And then that seasonal risk adjustments as a tool for shared reliability in the social context. And then thinking about the transparency you emphasized and how that can kind of get a connection to the community. Paul just typed in and asked about getting a copy of the presentation, and I'll work with Kit to find some version of it that we can share, whether it's a PDF or something else, and then we'll make that available on the Southwest Consortium webpage. And I'm guessing, well, maybe you want to touch on this yourself, Kit. There are probably similar resources on a PODS project page. I'm just guessing here.
Yeah, we actually have our own story map page that we've had a number of folks on our team that have been contributing to. I don't know if it's quite ready for release yet, but we do have a lot of materials, and we have an impressive publication record. The co-authors on this work have been publishing like crazy too, so we also have a lot of really nice case studies and then novel ideas about how you can kind of apply this framework.
Great, thank you. And I'll while we're waiting for other folks to chime in, I'll abuse my facilitator privilege and ask a question. And that is, so you talked a little bit about the machine learning. Do you feel like there's an opportunity in that aspect of the PODS work to improve or expand? I guess my sense as a layman is that that's an area that's rapidly expanding, whether it's just the computing power or machine learning algorithms in general are changing all the time. And so is that something that you feel like you may revisit and sort of take advantage of the latest available, or is that not where the trickiest parts of this problem are?
So it's actually twofold. We're actually thinking of this analytics challenge and in two steps, specifically for the potential control locations atlas, which is where we use machine learning. First of all is just getting better data that we can feed to it and more data so we can account for more extreme conditions. And that's ways that we can improve our current framework. That wouldn't be changing the platform, but it would be changing some of the inputs to hopefully give us more accurate results. But the current platform is actually very restricted in terms of input information that it can take. And so we actually have hired another team member to really blow up the current system and start to account for daily weather changes, daily fire progression. We basically made a whole list of the limits of what we currently do and try to account for those with our kind of version 2.0 or new version of the PCL model. We don't know when that's going to be operational, but we're excited. And with that, we are actually exploring deep neural networks. We're looking at random forest, a whole series of different platforms that might help us do that. And a big part of that too is accounting for the use of multiple core processors. One of the challenges we also run into is because the boosted regression system that we work now basically just works the heck out of a single processor because every time step is based on the previous time step. We can get around that using other methods. And so that's one of the things that we're working on now. And one of the other big things we're trying to do is pivot out from rollout and back into research. We now have 40 examples that this seems to work pretty well. And so we're making a pretty strong case to have an infrastructure so that this can become a standard. And so that we as researchers can move out of the rollout phase and the application phase and move back into making this a better product, and so we can get it actually improved.
Great, thank you. And some other folks have typed in questions here. Let's see if I can get back to the first one here. Dennis was asking whether you foresee this being an opportunity to meet U.S. Forest Service requirements for identifying the prioritized treatments that the forest supervisor certifies annually.
Absolutely. I think there's a lot of ways this can tier off of prioritization at an annual basis, but also if we look at things like the risk assessment and we can identify areas of high risk, those also become areas where you want to train your fuel management dollars to reduce that risk in any way you can. Try to mitigate it in some way. If you've already identified pod boundaries that are the best available locations, then you can reinforce them. Or if you've identified areas where you can't separate a high value a high value asset from an asset likely to be benefited from fire, then you now have an opportunity to train those fuel management dollars to create an opportunity. And that's something that we're actually engaging with in California and in other landscapes, is looking at, well, how would we use this type of information to target our fuel treatment dollars for maximum bang for the buck?
Great, thank you. And Lisa Bai is asking whether, and I think you may have mentioned this, but expansion to other federal agencies. Lisa's probably interested in BLM.
Yes, and actually the reason one of the things that has been really interesting about our initial engagement here on the Santa Fe and Carson landscape that I'm showing on this slide is that we now have a request from BLM to tier off of this, understanding that the BLM fire management objectives are not the same as the Forest Service. They have very different missions as an agency, but just having these opportunities pre-identified can really help speed up the decision-making process and understand where they're going to be most effective. And so we're trying to trying to accommodate all those different mission objectives, but also bring that into the risk and opportunity realm.
Great, and again, you touched on this a little bit, but the bringing the pods work into WFDS, and I guess you mentioned a couple of places. Maybe it was that map with sort of blue squares. There's some areas where that's already in play. Is that right?
Yeah. So actually, those blue squares were areas where we've applied these analytics, and well, I don't know how familiar all of the participants in this call are with WFDS, but WFDS is kind of a one-way street for information. you can upload things into WFDS, but you can't get them back out. And so with these risk management assessment team engagements, we will oftentimes kind of circumvent WFDS and get our analytics directly into the hands of the operations chief or into the hands of the incident commander, because WFDS isn't actually flexible enough to accommodate a lot of that information right now. That being said, WFDS Next Gen is in the process of being redeveloped at the moment. They're in, I think, 2 years into that process. Hopefully within the next 2 years, it will be ready to come out. And that is supposed to be a much more flexible platform that can actually call out different models and just bring in the results for display. And so the next gen of WFDS is going to be really designed to take this kind of information to help with decision making. The current version of WFDS isn't able to use this stuff directly. But that being said, we have had very good luck with, you can find the contact people on WFDS, email them, and immediately you can supply these things directly to them.
Great, thank you. And maybe our last question here comes from Matt, who asks, how tied to the land does fire behavior prediction for pods have to be? Could data from fire in neighboring, say, similar habitat inform fire behavior models, even if the data isn't on our forest PCLs?
Absolutely. And that is something that in our initial thought process for putting together this model was we wanted to basically just have regional models. So we were thinking if we could look at all of the forest habitats of the Pacific Northwest, maybe we would have a general Pacific Northwest type of PCL model that we could work off of. And that's something that we're still exploring. We've actually found that oftentimes that isn't the case because we're bringing in different management priorities. You can't, even on the same forest, you can't necessarily model the wilderness response the same as the suppression response, because you actually have suppression going to change fire behavior in some areas and not typically in those wilderness areas. And so that's kind of a moving target right now. We would really like to be able to harvest all the data off huge landscapes, throw it all into a model that can make sense of it, and then have these kind of generalized models that work in a lot of different places. But what we've often found is that ideally, if you can just keep it with a management priority and a general veg type, you can actually get a much more accurate model at the moment.
Great. Great. Well, again, thank you so much for a great presentation. You covered a lot of ground succinctly. And I think the video and your graphics really help bring it home. So thank you. And we'll have a recording available of this webinar soon. And that'll be on the Southwest Fire Science Consortium page. And thank you, everybody, for attending. And thanks again, Kit. We'll talk to everybody, hopefully, on future webinars.
Thank you, Xander.